Hello everyone, welcome to Concepts in Chemistry YouTube channel. So today by this video we are going to start a new series of questions, that is numerical analysis type of questions, or in short you can say NAT question series. So usually this type of questions asked in GATE and IIT-JAM exam. So this type of questions will be special for IIT-JAM and GATE aspirants, but this series of questions will also be helpful for all other competitive exam like CSIR-NET, BARC and any other MSc entrance examinations or other competitive exam regarding chemical science subject. So yeah, let's start the first questions of NAT question series. So this is the first video of NAT question answer discussion series. So let's start. Yeah, on point I have to mention that yeah, in this type of questions the answer should be a numeric value. That's why the name numerical analysis type of questions. So the final value of this type of questions should be a numeric, either it's double digit or single digit. So it should be a numeric value. We have to put the value in a blank space. So in this type of questions a blank space is there, we have to put the numeric value. So let's start the first questions from on point. Normally from maximum case they select NAT questions from physical chemistry. So मैक्सिमम केस में ये होता है फिजिकल केमिस्ट्री से मैक्सिमम NAT क्वेश्चंस ये लोग सिलेक्ट करता है एग्जाम में. सो लेट्स डिस्कस द फर्स्ट क्वेश्चन फ्रॉम molecular spectroscopy, physical molecular spectroscopy, or you can say microwave spectroscopy or rotational spectroscopy. So this is the first questions of NAT series. Let's see the questions. The angular velocity of a molecule of HCl at J is equal to 1 rotational level is. So we have to fill this blank space. So multiply 10 to the power is there. So if we do exact or right calculations, then we obviously we will get this kind of term, something into 10 to the 12 rad per second. So also given V means rotational constant of HCl 10.6 centimeter inverse. So this question is from rotational spectroscopy or microwave spectroscopy. HCl molecule is given. We have to find the angular velocity at J is equal to 1 rotational level. So these are J are the quantum numbers. So for rotational energies J can be 0, 1, 2, 3, so on. So J is equal to 1 means that is ground, and this is first excited state level. So first excited state level we have to find the angular velocity of HCl. Given B means rotational constant of HCl 10.6. Let's see the answer. So we all know from the quantum mechanical calculations, so the rotational motions we can write the energy expression for rotational motions, that is epsilon J in terms of centimeter inverse. If we write, then we will get B J into J plus 1. B is rotational constant, this value is h upon 8 pi square IC. I is the moment of inertia and C is the velocity of light, and J is the rotational quantum number 0, 1, 2, 3, 4, so on. If we want to write these expressions in terms of joule, here it is in centimeter inverse unit. If we want to write in joule unit, then we have to multiply this term by H and C. H means Planck constant along with C, velocity of light. So now this whole energy expression become in joule unit. So from quantum mechanical calculations, the energy expressions for rotational motions is Bj into J plus 1 into Hc joule. Now if I be the moment of inertia and W be the angular velocity, then the rotational energy become half I omega square joule. So Please keep in mind, this is from quantum mechanical calculations, from quantum mechanics, and this is from classical mechanics. So this is the energy expressions we are obtaining from quantum mechanical calculations. This is the energy expressions half I omega square, also in joule unit. This is from classical mechanics. So these are the two energy expressions, one from quantum mechanics and one from classical mechanics. In quantum mechanics expression, there is no angular velocity term, only rotational quantum number term. In classical mechanics, there is angular velocity term. So we have to consider both the energy expressions. Now let's see. If we compare the energy expressions, classical and this is quantum mechanical, at j is equal to 1 level. So if we put j is equal to 1, then it will become 2 BAC. So half I omega square classical energy and quantum mechanical energy. If we compare, then it will become this. So from these calculations, we find W. We found W equal to 4 root 2 B pi C. So so C B equal to H upon 8 pi square IC. We put the value of I here like that. So we can write I equal to H upon 8 pi square BC. H upon 8 pi square BC. We just put the value of I from this expression. From this expression, we put the value of I. If I become the position of B, then B goes to that position. H upon 8 pi square BC. So half into I, we put the value of I. H upon 8 pi square BC into omega square, W square, or you can say omega also. So angular velocity normally omega or W, same thing, 2BAC. Now omega square become 32. If we multiply this, pi square B square C square, so omega become 4 root 2 B pi C. Now we have to put the value of B. See, the value of B is given in centimeter inverse. See, the value of B is given as centimeter inverse. So we have to put the value of centimeter inverse. Now we have to put the value of pi here, not 180. We have to put in radian unit, means 22 by 7. 22 by 7 we have to put the value of pi, because in the answer radian per second is given. So we have to put the value of pi here 22 by 7, not 180. One point, that is the one major point we have to keep in mind. So and we have to put the value of C, means velocity of light, into CGS unit. 3 into 10 to the power 10 centimeter per second, not 3 into 10 to the power 8 meter per second. See, the B term is given in centimeter inverse. So if we put the value of C in CGS unit, centimeter per second, then this centimeter and this centimeter inverse will cancel out, only radian per second unit. तो फाइनली हम लोगों को क्या मिलेगा, रेडियन पर सेकेंड यूनिट मिलेगा, अगर हम लोगों ने वेलोसिटी ऑफ लाइट सी का वैल्यू सीजीएस यूनिट में यहाँ पर पुट करें. सो एट लास्ट द वैल्यू ऑफ ओमेगा और W become 5.64 into 10 to the power 12 rad per second. This is in centimeter inverse. This pi value we have to put 22 upon 7 in radian, and the velocity of C we have to put here in CGS unit. Then that centimeter and centimeter inverse will cancel out, only the rate per second will be left as a unit. So 5.64 into 10 to the power 12 means 10 to the power 12 radian per second is the angular velocity of HCl at J is equal to 1 rotational level. So see, now the answer we have to put here only 5.64. पहले से 10 to the power 12 रेडियन पर सेकेंड दिया हुआ था क्वेश्चन में, दैट वी हैव टू पुट दिस न्यूमेरिक वैल्यू. दिस इज द थर्ड डिजिट ऑफ न्यूमेरिक वैल्यू, थर्ड डिजिट नंबर 5.64. सो द आंसर ऑफ दिस क्वेश्चन इज 5.64. सो नॉर्मली NAT क्वेश्चन में ऐसा ही न्यूमेरिकल वैल्यू हम लोगों को पुट करना होता है ब्लैंक स्पेस में. सो द करेक्ट द एक्चुअल आंसर फॉर दिस क्वेश्चन इज 5.64. पहले से 10 to the power 12 दिया हुआ था क्वेश्चन में, नो नीड टू राइट अगेन, so you have to write only 5.64. so question में पूछा गया था angular velocity, but in quantum mechanical expression there is no angular velocity term. That's why we have to consider the classical mechanics expression, that is I half I omega square. And in the questions also rotational constant and J means rotational quantum number was given, so we have to consider the classical quantum mechanical expression also. So by comparing quantum mechanical and classical mechanics, we are at last we obtain the value of angular velocity, that is W or omega, that is 5.64 into 10 to the power 12 radian per second. So the correct answer is 5.64. So NAT 1 question number 1 is done. Let's move to the next question. So this is NAT question number 2 from Statistical Thermodynamics. So let's read the questions. A certain atom has threefold degenerate ground level, that is energy means epsilon 0 equal to 0. So ground level normally ground level जो energy होता है वो 0 ही होता है. नॉन डिजेनरेट इलेक्ट्रॉनिकली एक्साइटेड हमेशा 0 नहीं होता है, बट यहाँ पे epsilon 0 equal to 0 मेंशन किया. सो we have to assume, we should write that epsilon 0 means ground level energy is equal to 0. A non-degenerate electronically excited state at 3500 centimeter inverse. So the epsilon 1 means the first excited state, you can say this is ground and this is first excited state at 3500 centimeter inverse, and threefold degenerate level epsilon 2 at 4700 centimeter inverse. The partition function Q at 1900 Kelvin is. So question में क्या given है, we have to, in every competitive exam, first we have to read the questions at least 2 to 3 times, then we have to find what are the data given in the questions. So we have to find the value of partition function, molecular partition function at a particular temperature given 1900 Kelvin. So what is the given? Threefold degenerate. So from the statistical mechanics, there are non-degenerate system and degenerate system. So we all know the expression for Boltzmann distribution formula for non-degenerate system, for degenerate system, thermodynamic probability expression for non-degenerate system, for degenerate system. So see, in this case, a certain atom has threefold degenerate ground level, means the epsilon 0 whose energy value is 0, ground level का degeneracy है 3, means threefold degenerate means the degeneracy of the ground state is 3, and a non-degenerate electronically excited state, so epsilon 1. So the energy value of the epsilon 1 is 3500 centimeter inverse, means from 0 to the first excited state. That's why it's written here at 3500 centimeter inverse. So the energy value of epsilon 1 is 3500 centimeter inverse, and the degeneracy of the first excited state is 1. So when the energy state or an energy level is non-degenerate, so it means the degeneracy is 1. So non-degenerate energy level means the degeneracy of that energy level is 1. So in this case, the energy value is 3500 centimeter inverse, but the degeneracy of this excited state is 1, means non-degenerate. And again a threefold degenerate level epsilon 2 at 4700 centimeter inverse. So these are the corresponding energy value. Epsilon 0 equal to 0, epsilon 1 is equal to 3500 centimeter inverse, epsilon 2 equal to 4700 centimeter inverse. The degeneracy value of the ground level means G0 is 0 and C non-degenerate, so G1 means degeneracy of energy state 1 is 1, non-degenerate means degeneracy is 1, and threefold degenerate again epsilon 2, so G2 means degeneracy of energy level 2 is 3. What will be the partition function? ये पूरा क्वेश्चन रीड करने के बाद हम लोगों को इतना सारा डाटा मिला. Now let's write the datas and try to find the partition function. So we all know the molecular partition function for degenerate system is that is Q, symbol of molecular partition function, summation of Gi, that is degeneracy of ith species or degeneracy of ith level, and exponential minus epsilon I upon kT. Epsilon I is the energy of ith level, and Gi is the degeneracy of the ith level. So according to the questions, see G0 means the ground state. क्वेश्चन में दिया हुआ है थ्री फोल्ड डिजेनरेट ग्राउंड स्टेट is 3-fold degenerate and the energy value is 0. Second, non-degenerate electronically excited state at 3500 centimeter inverse. Non-degenerate means degeneracy is 1. So G on is equal to 1 and the energy value is 3500 centimeter inverse. And if we want to write this value in joule, then we have to multiply this value by AC. We just saw in the first question also, if the unit is centimeter inverse, and if we want to write the energy value in joule unit, then we have to multiply this term by AC, Planck constant along with velocity of light. Now if we calculate this, see, और एक पॉइंट मुझे मेंशन करना है, एक इंपॉर्टेंट पॉइंट है, जो ये नेट क्वेश्चन में मैक्सिमम केस में यूनिट में थोड़ा प्रॉब्लम होता है. सो हम लोगों को यूनिट कैलकुलेशन करना पड़ता है, यूनिट ठीक ठाक से यूनिट मैच करना होता है. सो यूनिट अगर गलत हो गया तो आंसर भी गलत हो जाएगा. सो हम लोगों को यूनिट के ऊपर मैक्सिमम ध्यान रखना होता है. दिस टाइप ऑफ क्वेश्चन ड्यूरिंग सॉल्विंग नेट क्वेश्चन we have to focus on unit. So see, this is in centimeter inverse. So we want this value in joule, then we have to put this H in its SI unit, means 10 to the power minus 31 joule per second, 6.626 10 to the power minus 31 joule second, and the velocity of light again in centimeter, means CGS unit, 3 into 10 to the power 10 centimeter per second. Then this centimeter and this centimeter inverse will cancel out, only this second and this second inverse will cancel out, only joule will be left. So then we will obtain the expression as joule unit. If we put here arc per second, then we will get the energy as arc, not joule. So concentrate on the centimeter inverse, what we want, what we have to put. Centimeter inverse energy is given, we want joule, we have to multiply in HC by HC. So we have to put the HC value in joule second, that is 6.626 into 10 to the power minus 31 joule second, and also the velocity of light we have to put in centimeter per second. Then this centimeter inverse and this centimeter will cancel out, this second inverse second cancel out, only joule will be left. So we obtain epsilon on, the energy of epsilon on equal to 6.95 into 10 to the power minus 20 joule. If we calculate this will be the result. Same case for epsilon 2, 4700 centimeter inverse, mean 4700 into HCA joule, 4700 centimeter inverse, 6.626 into 10 to the power minus 31 joule second, again 3 into 10 to the power 10 centimeter per second. Then we will obtain the value as joule unit, 9.34 into 10 to the power minus 20. So temperature is given 1900 Kelvin. So now from this expression Q is equal to, so summation of Gi exponential minus epsilon I upon kT. So in this case 3 energy level and 3 degeneracy are given. So we have to consider the 3 term. First G0 exponential minus epsilon 0 upon kT, G on exponential minus epsilon 1 upon kT, G2 exponential minus epsilon 2 upon kT. This is for ground state, this is for first excited state, this is for second excited state. So 3 into, if we put this epsilon 0 is equal to 0, then it will become 0, plus 1 means G1 is equal to 1 exponential minus this whole energy value. And yeah, in the questions maximum case में आप लोग सोचिएगा ये k का वैल्यू मीन्स बोल्ट्जमैन कांस्टेंट का वैल्यू प्लीज याद रखने का कोशिश कीजिएगा. मैक्सिमम केस में ये k का वैल्यू अगर दिया हुआ है क्वेश्चन में तो बहुत सही है, इट्स गुड फॉर अस. बट अगर k का वैल्यू मीन्स बोल्ट्जमैन कांस्टेंट दैट इज 1.38 10 to the minus 23 जूल पर केल्विन, अगर ये वैल्यू नहीं दिया हुआ है तो प्लीज आप लोग ये वाला एटलीस्ट बोल्ट्जमैन कांस्टेंट, प्लैंक कांस्टेंट और बाकी कुछ कांस्टेंट है, उन लोगों का वैल्यू हम लोगों को याद रखना पड़ेगा. अगर क्वेश्चन में नहीं दिया हुआ है तो हम लोग फंस जाएंगे वो वाला क्वेश्चन सॉल्व करने के लिए. क्वेश्चन इजी हो रहेगा बट वैल्यू याद नहीं रहेगा, इसलिए हम लोग क्वेश्चन सॉल्व नहीं कर पाएंगे. तो प्लीज ये वैल्यू याद करने के लिए याद करने का कोशिश कीजिएगा. सो दिस इज द वैल्यू ऑफ बोल्ट्जमैन कांस्टेंट के 1.38 10 to the minus 23 joule per Kelvin. See, In these expressions, the energy is in joule. If we put the value of Boltzmann constant in joule per Kelvin, then this joule and joule will cancel out, K inverse and K will cancel out, so it become unitless. If we put here arc per Kelvin, then we will not get the actual, so then the unit should not cancel out. So unit में कुछ problem हो जाएगा, so we have to put in joule per Kelvin. Here see centimeter inverse velocity of light semi per second, but we are putting here A is at joule second, then we will obtain as joule unit. See, we have to put here K value means Boltzmann constant value joule per Kelvin, then we will get unitless quantity. So and this third term 3, so G2 means the designated term is 3 and epsilon 2 means 40, we calculated here 9.34 10 to the power minus 20 joule. So it's again 9.34 into 10 to the minus 20 joule, again 1.38 into 10 to minus 23 joule per Kelvin, 1900 Kelvin. So if we put this value and if we calculate, so calculator उसमें अलग होगा, IIT-JAM और गेट जो होता है कैलकुलेटर अलग होता है. अभी तो नेट में भी लास्ट जो नेट हुआ उसमें भी कैलकुलेटर था, सो अभी शायद ऐसा कुछ क्वेश्चन सॉल्व करने के लिए दिक्कत नहीं होगा. सो कैलकुलेटर अलग होगा, सो कैलकुलेटर आप लोगों को मिलेगा ड्यूरिंग एग्जाम हॉल, सो प्रॉब्लम नहीं होगा. इफ वी कैलकुलेट दिस टर्म वी विल फाइंड फर्स्ट टर्म 3 एक्सपोनेंशियल 0 मीन्स 1 and exponential minus 2.6 from second term, 3 into exponential minus 3.56 for third term. Now it will become 3 plus 0.07 plus 0.085, it's become 3.155. so the correct answer होगा 3.155. अगर क्वेश्चन ब्लैंक में पूछा गया up to 2 digit after decimal point, 2 digit after decimal point, so you have to write 3.15. After 1 digit after decimal point we have to write 3.1. so then the answer will be 3.155. I think ये वाला questions I am really want to tell you something that this type of question solving seriously is not only for GATE and IIT-JAM. so इस type of questions MCQ format में भी पूछ सकते हैं, जो मैक्सिमम केस में पूछते हैं CSIR-NET और बार्क और एनी अदर MSc एंट्रेंस एग्जामिनेशंस और कॉम्पिटिटिव एग्जाम रिगार्डिंग केमिकल साइंस पूछ सकते हैं. सो बट दिस टाइप ऑफ क्वेश्चन इज स्पेशल फॉर GATE and IIT-JAM aspirants, but it will also be as much as helpful for all other aspirants from CSIR-NET or BARC or any other MSc entrance related exam. so NAT 2 is done. I think ये वाला कैलकुलेशन ठीक ठाक ही नॉर्मल कैलकुलेशन है, बस हम लोगों को ये थोड़ा समझना था about the degeneracy of this energy level. First energy level energy is 0, degeneracy is 3. Second energy level energy is non-degenerate, so non-degenerate means that degeneracy is 1. Please keep in mind non-degenerate means degeneracy is 1 not 0. And the third energy level mentioned as threefold degenerate. Temperature is given, we have to find the value of molecular partition function. So let's move to the next questions. Question number 3, NAT 3 from physical photochemistry. So the question says that when hydrogen iodide Hi is irradiated with 2530 angstrom wavelength, it is observed that 1.85 into 10 to the minus 2 moles decompose per kilocalorie of energy absorbed. The value of quantum yield is. हम लोग एक लाइट यूज कर रहे हैं as a external source to irradiate Hi. Now 1.85 into 10 to the minus 2 moles of Hi decomposed per kilocalorie of energy absorbed. 1 kilocalorie energy absorb करने के बाद इतना मोल डिकम्पोज हो रहा है यूजिंग दिस वेवलेंथ ऑफ लाइट. Hi का इतना मोल डिकम्पोज हुआ 1 किलोकैलोरी एनर्जी एब्जॉर्ब करने के बाद. सो व्हाट विल बी द क्वांटम यील्ड और क्वांटम एफिशिएंसी. So let's see the questions. So we can define quantum yield or quantum efficiency like that. number of moles reacted or formed. For product it is formed, for reactant it is decomposed or reacted upon number of Einstein absorbed. So Einstein means Einstein means Avogadro number of photons. So 1 mole of photons called 1 Einstein. So 1 moles of photon calls 1 Einstein. Now we can, this is the general expression for finding quantum yield or quantum efficiency. We can modify this expression like that. If the process means these reactions is carried out for a specific period of time, then we can write that number of moles reacted or formed in a specific time interval, number of Einstein absorbed in a specific time interval. Now we mention the time, how much time the reaction we done. So number of moles reacted or formed in a unit time. If the time is unit, means it's 1 hour, 1 minute or 1 day. Unit time, number of Einstein absorbed in unit time. So then this term, number of moles reacted in unit time, is known as rate of reactions, and number of Einstein absorbed in unit time is called as intensity of light. Number of Einstein absorbed in unit time is intensity of light, that is IA. So phi means quantum yield or quantum efficiency is equal to rate upon intensity of light. So this is the whole, this is all the expression of quantum yield or quantum efficiency. Now we will consider only these expressions for this question: number of moles reacted or formed, number of Einstein absorbed. Keep in mind that so quantum yield or quantum efficiency, we are considering only these expressions for this question. For solving this question, we are considering this expression only: number of moles reacted, or you can say number of mole formed for product, number of Einstein absorbed. So amount of energy, how much energy absorbed? 1 kilocalorie, that is 1000 calorie. Number of moles of HI decomposed, 1.85 into 10 to the minus 2 moles. So number of moles reacted means डिकम्पोज हो गया, नंबर ऑफ मोल्स फॉर्म्ड मींस आफ्टर जितना डिकम्पोज होगा उतना ही तो फॉर्म होगा. सो दैट इज सेम थिंग, नंबर ऑफ मोल्स रिएक्टेड और डिकम्पोज और फॉर्म. So we also know the energy of 1 mole of photons is known as Einstein. So energy of 1 mole of photon is known as Einstein, but here number of Einstein is given, not number of photons. 1 mole of number of photons is known as Einstein, but in the expression number of Einstein we have to find, not number of photons. Number of moles reacted or decomposed is given in the questions, but we have to find this much energy अगर वो एब्जॉर्ब करते हैं ये वाला रिएक्शन में यूजिंग द लाइट ऑफ वेवलेंथ 2530, देन कितना आइंस्टाइन एब्जॉर्ब होता है. दिस मच एनर्जी इज equivalent to what how much number of Einstein. This much energy is equivalent to how much number of Einstein. Now we have to find that. So this E means Einstein equal to Na, Avogadro number, into epsilon. This epsilon is the energy of each photon. So energy of each photon is epsilon is hc upon lambda. This is energy of each photon. Now the Einstein, one Einstein can be written as Na into hci upon lambda, means Na into epsilon, means Avogadro number of photons. Avogadro number of photon, energy of Avogadro number of photons is equal to Einstein. Now if lambda is expressed as angstrom unit, then we can write or we can calculate Einstein equal to, by putting this value, 2.864 into 10 to the power 8 calorie per mole. This is in calorie unit, this lambda is in angstrom unit, calorie per mole. So some basic calculations or basic calculation is there. So we already uploaded one video, that is chemistry concept booster, question number 18. So you will find the link somewhere, I button. So please click to see the calculations. So the basic calculation, how we can find the energy value in different units, calorie, arc, joule. So Einstein, how we can calculate the Einstein value in different unit, whether there is lambda in angstrom unit or lambda is in centimeter unit. So we already discussed details in the chemistry concept booster question number 18. You will find somewhere in the I button. Please click to see the basic calculations. So in that video we will discuss how to calculate Einstein for in different unit, in calorie, in joule, or in arc, and lambda is in centimeter or lambda is in angstrom. In both case we showed there the calculations. So if we express lambda as angstrom unit, so if lambda is an angstrom unit, then the Einstein we can write as 2.864 into 10 to the power 8 calorie per mole. This is in calorie unit because the energy is given in calorie unit. So if we put this all values, then it will become 2.864 into 10 to the power 8 upon lambda calorie per mole. So in the questions they used lambda equal to 2530 angstrom. So we have to put the lambda here. In place of lambda we have to put 2530 angstrom. 2530 we have to put, then we will find the actual Einstein. So now one Einstein become 2.864 into 10 to the power 8 upon 2530 calorie per mole. So one Einstein is equal to 1.13 10 to the 5 calorie. So one Einstein per mole means we are considering 1 mole. So that's why per mole. Here we are considering 1 mole means Avogadro number of photons. So one Einstein equal to, we can write 1.13 10 to the power 5 calorie per mole. Now 1.13 into 10 to the power 5 calorie equal to 1 Einstein. Thus we are showing here in opposite. 1 Einstein means 1.13 10 to the power 5 calorie. So 1.13 10 to the power 5 calorie we can write is equal to 1 Einstein. Now we have to find 1000 calorie because in this question during the reaction 1000 calorie energy absorbed. So 1000 calorie absorbed is equivalent to 8.84 10 to the power minus 3 Einstein. So from this whole calculation हम लोगों को एक ही मोटिव था, आइंस्टाइन निकालना. 1000 calorie energy is equal to or equivalent to how much number of Einstein, because जो एनर्जी एक्सप्रेशन है हम लोगों को उसमें नंबर ऑफ आइंस्टाइन एब्जॉर्ब पुट करना है. नंबर ऑफ मोल रिएक्टेड और डिकम्पोज ऑलरेडी दिया हुआ है क्वेश्चन में. हम लोगों को ढूंढना है अभी नंबर ऑफ आइंस्टाइन कितना एब्जॉर्ब हुआ. सो नंबर ऑफ आइंस्टाइन, वन आइंस्टाइन मीन्स एवोगाड्रो नंबर ऑफ energy of Avogadro number of photon. Energy of one photon is this epsilon h by lambda. So if we put this all value and lambda is expressed in angstrom unit, then we will get one Einstein equal to 1.13 10 to the power 5 calorie. Now this mass calorie is equivalent to 1 Einstein. So 1000 calorie is equivalent to 8.84 10 to the power minus 3 Einstein. Now see. So now the quantum yield or quantum efficiency become 1.85 into 10 to the minus 2, means this is the number of mole of HI decomposed, or you can say number of product formed or number of HI reacted. This is given number of moles upon number of Einstein absorbed. So from this whole calculation we found that this mass Einstein is absorbed during this reactions, or this 1000 calorie energy is absorbed and 1000 calorie energy is equivalent to 8.84 10 to the minus 3 Einstein. We have to put this Einstein in these expressions. It will become 2.09. So the quantum efficiency for this reaction is 2.09. So I hope आप लोग समझ गया ये वाला क्वेश्चन. जो जितना था मैंने कोशिश किया डिटेल समझने के लिए. बस I think and I believe that you all understood what I am trying to say or what I was trying to say. So these three questions will be very helpful. So yeah, now I can say that after discussing these three questions, so मैं ये कह सकता हूँ क्या आप फोटोकेमिस्ट्री से रिगार्डिंग क्वांटम यील्ड और क्वांटम यील्ड एंड that is from statistical thermodynamics regarding degeneracy और energy related कोई भी अगर न्यूमेरिकल क्वेश्चन कोई भी एग्जाम में, आइदर इट इज नेट, गेट, बार्क, IIT-JAM और एनी अदर एमएससी एंट्रेंस में अगर कोई क्वेश्चन पूछेगा तो आप लोग शायद सॉल्व कर पाओगे. सो in this video we discussed 3 questions from 3 different part of physical chemistry. I hope you guys understood all the things जो हम लोगों ने डिस्कस किया. कौन सा पॉइंट याद करना था और कौन सा पॉइंट आप लोगों को थोड़ा ज़्यादा ध्यान देना चाहिए वो मैंने भी डिस्कस कर लिया. मैक्सिमम केस में यूनिट में थोड़ा ध्यान देना लगता है, यूनिट कौन सा दिया हुआ है, यूनिट आंसर में कौन सा यूनिट आंसर में क्या चाहिए था और जो डाटा गिवन है उसका यूनिट क्या है. सो ड्यूरिंग सॉल्विंग दिस टाइप ऑफ क्वेश्चंस, NAT questions, please focus on the unit of each term. So I hope you guys enjoy this video, and yeah, this will be helpful for all other MSc entrance examination including IIT-JAM and GATE. So these are the special for IIT-JAM and GATE, but also very helpful for all other competitive exam regarding chemical science subject. So yeah, that's all for today. Thank you for watching. I hope these 3 questions will help you a lot to solve different type of relatable questions from this topic. So thank you guys, thank you for watching. So stay tuned and stay safe, stay healthy. So we are going to discuss lots of questions from different topic, from different branches of chemistry in our upcoming video. So stay tuned. Thank you again. Bye.